Now let's go back to this customer repository that we created. Okay, and I've just got an interface here, which is a customer repository, and then I've got an implementation, which is SQL customer repository. Now, I just want to make it clear, and a very big disclaimer, probably the vast majority of implementations of repositories are done incorrectly because supposedly you're only meant to read values and not really store and get by IDs and get by names and get by this and get by that. But we're going to use the pragmatic or mainstream definition of a repository. And when you're implementing repositories, a lot of times in code, you see that you constantly follow the same kind of pattern. So customer repository is going to have basically the same kind of behavior as, for instance, an employee repository. So of course, if I go and do an employee repository here, and then I do, let's say, for example, fun store object, and now this is going to be an employee, and then it's going to have also some default implementation, or maybe it might not, and then I do a get by ID, and I do ID int, and then here employee, okay? We can see that we are basically repeating code. We're taking a custom repository that has a store and a get by ID, and we're taking an employee repository that has a store and a get by ID. And the only difference between these two is the actual type that it returns. Okay, so here we see it's taking a customer, returning a customer. Here it's taking a customer, returning a customer. Now, obviously, if you are not new to programming and you've already seen this before, you know how we resolve this, and it's called generics, which is basically creating some kind of generic class that takes some parameter, which is called the type parameter, and that varies. The actual type varies. And Kotlin, fortunately, has support for generics, and let's see how that's done. So I'm going to create an interface now, which I'm going to call a repository. No longer a customer repository or an employee customer repository, but just repository. And what I'm going to do is I'm going to say that this is a generic type and takes the type parameter t, and then this has a bunch of methods. So for instance, fun get by ID, and it's going to take an ID of type integer, and it's going to return a t. Then it's going to have a fun get all that's not going to take any parameters, and it's going to return a list of t's. Okay? So this is the actual type parameter. And for now, forget about this warning, because we'll see this later on, which says something about out variance. So don't worry about that for now. Now, let me go ahead and implement this. And I'll just let the IDE do that for me. So I'll say implement interface, and I'm going to call it. This is going to be a customer generic repository. And I've named it generic because we already have a customer repository, and I don't want to have conflicts. So which members do I want to select? And I'm going to say both, and there we go. So I'll go ahead and, we're going to leave the unsupported exception there right now because we're not worried about the code. What we are interested in is how this is implemented. So this is now a customer generic repository that takes a type parameter t, and then it returns that type. So going back to generics, and if we try and use this, when I create a customer repo, I create an instance of a customer generic repository, and I pass in customer. Now, you might have noticed one thing. This is actually redundant, right? Because I no longer need to call this a customer generic repository, because this is telling me what type of repository it is. So let's go ahead and refactor that, and we'll just call it generic repository. And now we're seeing that this is a generic repository of type customer. So the type parameter here is customer. And then we know that, for instance, when I do a val customer repo get by ID, we can see that it's returning a type customer. When I do customers customer repo get all, again, if we invoke completion, we can see that it's returning a list of customers. So this really allows us, like in any other language, to cut down an enormous amount of boilerplate code where basically we have the same kind of requirements in terms of whether it's an interface, whether it's default implementations, etc. The only thing that varies is the actual type that we're working with. Now, in this case, what we have is a generic repository with a type parameter t, but we could also implement this in a slightly different way by using generic functions. So let's say, for instance, that I have an interface of type repo, and not to name it just repository. This is a variation, so to speak. And this is going to have a function, again, get by ID, that's going to take an integer, and it's going to return a t. Now, where is t? You see that t is now giving me an error. So I can say that this function is generic. And that's how we denote it. We say that this takes a type parameter. We put it after the keyword function and before the function name. And let's go ahead and do the same for get all. And now if I go ahead and implement this, so I'll say class my repo, we can see that it's kind of similar to what we saw, except now the type parameter has moved from the class to the actual functions. Now, you would ask, would I do this? No, I actually wouldn't do this, because it really doesn't make sense if all of the member functions in a specific interface or in a specific class have this same type. This would only make sense if these were different types. So for instance, if I had a different type here, then it would make sense, because I can't represent this much with a single type parameter to the interface. And also notice that this R could be called anything. I mean, I could call this we could rename this to, for example, entity type. It's absolutely fine. We just kind of follow the convention of many programming languages, which is just using single letter to represent type parameters. So again, to summarize what we just saw with inheritance and generics, we saw that by default classes are final in Kotlin. This means that if we want to inherit from a class, we have to use the open annotation. Abstract classes are similar to interfaces, but they allow state and default implementations, which abstract classes also do, but they're also similar to Java interfaces, Java 8 interfaces, which also allow support for default implementations. Kotlin also has support for generic types and functions, and we've seen how we can basically reuse code by just passing in type parameters, and we'll dive a little bit more deeper into generics in the advanced section of this course.